So here's what's on the docket for today. I kind of was walking into class and I had that Aerosmith head song in my head, getting ready for the big time, getting ready for whatever, however it goes, right? But I feel like what I've learned since I last saw you is like, whoa, getting ready for the big time. And like passing these skills on to you guys today, you're going to have it all. You'll have it all, baby. You're going to have it all. You'll have it all. You're going to have all the pieces because got Google Cloud Storage working. So being able to put files, whether they're images or whatever files, up to the cloud. Like you guys have everything to build awesome web apps. We have all of these code samples here of every step along the way. They're just pieces. You've seen it, you've been exposed to it, now you can start building something. Oh, how did I do that? Go look it up, see the code, put it into your own application, integrate it all, make it work. So we're going to see Google Cloud Storage working today. And we're also going to see that implemented with a sample movie website that lets you upload movie posters. And then it'll also do a web API to transform Markdown into HTML. And we'll talk about why that is why you wouldn't want people just to enter straight HTML, right? But if they enter Markdown, it's a little bit of a better solution. And then we're going to look at another web API where we could just get GIFs. And so here's a preview of that right here. And this is like my favorite GIF right there of the cat. I don't know if that cat made it because that looks kind of high. Because there's the treetops, and here's like a tower. But I love the commitment. And this was just a little too slippery for the cat, right? Like he's just like, I'm still trying to reach it all the way down, right? Like, let me get there. Didn't make it. So maybe that's the last moment of that cat's life, but it's brought me some good humor. And what better way to go out, man, if you're going to go out than making a few people laugh. So hopefully it's not till the end of your life. So we're going to see how to kind of use a web API, and then we're going to see how to create a self-destructing message. Dun, 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 dun. Like Mission Impossible, this message will self-destruct in 5 minutes or whatever it is. So that's what's on the docket. So some really good stuff. And inside self-destructing message, we're going to see how to do crypto. And so we're going to see a little bit about encryption. So some really exciting things to look at today. And the first thing I wanted to kind of show you when one of the things that came to mind for me, because we talked about this at summer boot camp, was Kim.com. And if you don't know who Kim.com is, go Google 60 Minutes Kim.com, and they have a really great episode on them. Ironically, if you go to 60 Minutes website, they tell you that you have to pay to watch this video, but if you go to YouTube, you could just watch it for free. and the entire video about Kim.com is about intellectual property. So I'm sure 60 Minutes is making money via YouTube, right? When you watch it there, that's another view for them, and they get ad money or whatever. So that's Kim.com has created a Mega Upload, and Mega Upload is a place where there's some piracy, so people could upload files and share them with others. And he made like $600 million off of it. And now he lives in New Zealand. He's wanted in the United States as a fugitive to stand trial. And, now he has another website, but everything that gets uploaded gets encrypted. So he could say, I don't know what's on my server. It's all encrypted, And so people upload stuff, and he could, claim innocence. Like, I don't know what they're uploading. It's a place you can securely upload something. And cryptography is also an interesting thing just to look at because of what's been in the news with terrorists encrypting messages. And so this stuff that you'll see today is completely secure cryptography that if you were to implement this, you could communicate securely between yourself and whoever you want to talk with. And so that's pretty amazing, pretty powerful to think that you could deploy something like this, right? Like you could build this. So basically, things are encrypted and stored. That's it. It's just email that's encrypted and stored. That's what Proton Mail is. So, obviously because terrorists use this stuff to, hide their communications, that's something else to think about. It's been in the news. All right, so that's that. So what do you guys want to see first? Google Cloud Storage or Giphy or self-destructing message and cryptography? Any preference, or just knock them out one by one? Giphy, I think Giphy is kind of light and easy to look at. So let's look at the Giphy. So we already saw it going, and what happens when we run it is it goes and grabs all the URLs and shows the GIFs. And so there's an API, and that API is listed for us right here. And so it's right at that place right there. And so if we go look at that API, right, the Giphy API, and it tells us a little bit about it. Giphy is an animated GIF search engine. Giphy API is open to the public. We have instituted a simple single public beta key system to let anyone try it out. The API key is required for all endpoints. So here's the key, and you can request a production key, and provides different JSON endpoints, whatever. And then here's the host, and then here's again the key, and then here's like an example of how you'd use it. So we could just grab this, and we could paste that into URL, and you can see what we're searching for there is funny cat. And so if I paste that in, I get this. And you saw my browser kind of flash. That's JSON. And the reason that it comes out formatted nicely, and the reason my browser flash is in here under extensions, I have a JSON view. So you could just, it's a Chrome extension. You could Google that, and it takes your JSON and formats it nicely. Right? And you could also see my other extensions here: Postman, Live HTTP headers, JetBrains, HTTP headers, HTML outliner, Google Slides, Sheets, Hangouts, Docs offline, Google Docs, AVG, App Engine, Page Speed, Service Preview, Accessibility Developer Tools. So those are, but that's JSON view. So here's the JSON, and you can see here it's another example of the same stuff, right? And so in our code, we had to, what's going on? So since we're on App Engine, we can't just, what is it that we would normally use to get a URL? We would use godoc.org/net HTTP. We would normally use get. So get and give it a URL, and gives us a response and an error, right? And so get issues get to a specified URL. If the response is one of the following redirect codes, get follows the redirect up to a maximum of 10 directs. But we can't just use that on App Engine, and we could try. Like we could even just pass in this information and see what happens. So. Sorry, I don't know why I call it handle. There we go. I'm glad you're here, man.
Hey, thank you. I'm glad I'm here too. Glad everybody's here.
Because you're going to see some cool stuff that's going to make you happy today. I don't want that.
So I can't use it on App Engine?
Because App Engine runs in a sandbox. And so there's certain functionality that's restricted. And so one of the things, I guess, is they don't want you just to go out and grab a bunch of URLs. So we could even just try putting this in here instead of that one. Boop, 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 boop. All right, let's see if, let's get rid of that error. See if that works, and maybe I'm wrong, but. So I think this is, that's not running anything there. And then here, Control C, Control K, and go app serve. And so we just got some sort of an error. And failed to build Go application. No new variables on left side, 19. So 19, no new variables. And response body. What am I going to, I'll call that HD sample, I'll call that response. Okay, so let's see what happens if we go to sample. The runtime process gave bad HTTP response. Runtime error, invalid memory address or nil pointer dereference. Just looking to see if it gives us any type of a line number or anything like that. So we can look at terminal here. So here we were running. Right there we started running. And that's kind of successfully running. And then default get and runtime error, invalid, HTTP panic, serving invalid memory address and nil pointer dereference, go routine 7, running that. So no line numbers or anything like that. So the reason it's doing that, 98% certain, is because we're not allowed to use get on App Engine. So instead of get, take that out, take that out. We'll use, we'll get our context, App Engine new context, and then we could use URL fetch client. And so URL fetch is coming from App Engine URL fetch. Get that out of there. And Control C, Control K, go app serve. So App Engine, and then down at the bottom here of App Engine, we have all the different directories or packages, sub-packages that are available in App Engine. So here we have URL fetch, provides an HTTP round tripper implementation for fetching URLs via App Engine's URL fetch service. And so we come down here, and then we have this in the index. So variables, client, transport. The variables, error truncated body, client returns an HTTP client using default URL fetch transport. The client will have the default deadline of 5 seconds. We'll check the validity of SSL certificates. Any deadline of the provided context will be used for requests through this client. If the client does not have a deadline, then a 5-second default is used. So we can look at an HTTP client. An HTTP client is in net HTTP, and a client has transport round tripper, check redirect, jar, that, right? So it's a struct. But then we also have do, get, head, post, post form. And so we're going to use get, issues a get to the specified URL. If the response is one of the following redirect codes, get follows the redirect after calling clients, da da da. So we get a response back from get, and a response has a body, right? So that's what we use here. So we get from the package URL fetch, we say give me a client, and that takes a context. And so once again, that code is right here. Client takes a context, and then we get a pointer to a client. And with a pointer to a client, so we have a client, right? With a pointer to a client, we now have all these methods we could use. And this is, whoa, sorry. This is from the NetHTTP package. And so client has all these methods. Do, get, head, post, post form. So now we can use our client to do things like get a URL. And so it's App Engine's way of grabbing a URL. That's how you do it. And so we go get that URL and we get a result. And then that result, right, when we do a client get gives us a response and an error. So the response has a body. And that's again from NetHTTP. And so our response body, our response result, right here, we defer the close of that. And the reason we defer the close is because it implements IO read closer, so it's something that needs to be closed, right? A reader and a closer, so we need to close it. And then we use result right here to get the results out. So we had to create a struct to sort of catch the results. The results are coming back as JSON. When you're going to work with JSON, you're going to either use Marshall, unmarshall, or you're going to use encode, decode. Ruben, good to see you. We got the full crew today, man. We got a full house. We got 2, 5, 7 people. Awesome. So when you're working with JSON, you have encode, decode, and Marshall, unmarshall. What's the difference? When do you use one versus the other?
Marshall makes a string.
Yeah. So Marshall and unmarshall is just I'm working with strings. I'm in my code. I have a string. It's JSON. I'm going to unmarshall that and put it into some sort of a struct. Or I have a struct. I want to turn it into a JSON string. I'm going to marshal that, right? And I'll turn it into a string. Encode, decode is used if you have a stream. Not a string, but a stream. It's flowing in as a stream from somewhere, or it's flowing out in a response stream, right? And so here I'm using JSON new decoder, and it's the result body, which is streaming in. And so I'm going to decode that. Where am I going to decode it to? I'm going to decode it to this object. And that object's right here. And this object's got a pretty crazy looking data structure. But that data structure pretty much just mirrors this data structure right here. And so we start off with a structure. So we start off with a structure, right? And then we have data slice of objects, and we have data is a slice of some objects. Here are the objects it's a slice of. And I could click these right here, right? Data is a slice. There's a lot of them. Seems like it should be a quick way to do this. I got a lot. I'm going to stop. Right? But data is a slice of objects. So data is a slice. And since they're objects, it's more struct. Right? And what's inside each one? I have another object. So a slice of objects. So there's the object. And then I have some fields. So here's a URL field. So I'm going to grab that. I want that. So URL string, URL string. And then I have here images. And here's images. And that's another struct. So that's a field. And it points to another struct. And so images is another struct. And then inside images, right, there's a original. So inside images, there's original. And here's original. Wait, is that right? Original. Here's original. And that's a struct, right? So there's the object. And it has a field URL. So I'm getting that one too, right? So I grabbed this URL field, which is this. And I grabbed this URL up here, which is this. Right, so it's just the URL. And so there's a lot of stuff I'm not grabbing. And so when I decode it, if I don't have a field in my struct, it just ignores it. And only the fields I have, it puts that data into the right place. And you'll notice that, here this is capital, but here this is lowercase. It seems to work. If it didn't, if I needed to map that, I could add right out here, like there's those tags that you could add. And so I don't remember exactly how to do that. So godoc.org. And where do I find Marshall and unmarshall? So I could come here and I could be like, or decode JSON. JSON is in encoding JSON. And then I have encode. I'm doing a new decoder. So decoder and new decoder. And the thing that I was going to say is the tags. So where are the tags? So I could just Control F tags. And look over here on the right and see where are tags mentioned. Actually, I thought they were called tags. Well, maybe it's just tag. So here are some tags. Field appears in JSON as key my name. Field appears in JSON as key my name, and the field is omitted from the object if its value is empty. Right. So if I needed to map that, I could do field int JSON my name, and here I have URL string JSON URL. So that should still work if I needed to map it with a tag. I was saying in JSON it's called this, and I want to put it to that. So let's see if that still works. So it rebuilt there. And so I should be able to go and ask for this file again at localhost. So it worked. Cat's like, I could do that. And then once we get that put into our object, right, this object, we could come down here and we could range over object, and we're ranging over data, which is all of this, the slices, right, the slice of struct. So it's, slice of struct, and then inside we're going to have the URL, and then we're also going to have images, which is another struct. So we have image URL, image, images, original URL. Image is right here, and then images is right here, and then original and URL. And so then that prints all that out. So when we run it, we get that URL printed out. Right? We get a link to it, and then we also get original URL, which shows it like that. So %v, and image source %v. Because this one will take us to that page where it shows it like that. So that's pretty cool. Anybody have any questions about it? You're looking at stuff for the future.
How would you hide the URLs? Like you just have the gifs.
So I just want to print it here, so I could. How would I hide the URLs and just show the GIFs? So this is format printing. And it's fprintf, so to a file, or it takes some sort of a writer here. So the writer is our response. And what are we printing? We have to, when we look at format printing, so file, format printing, these routines end in f and take a format string. Fprintf formats according to format specifier and writes to the writer. It returns the number of bytes written and any write error encountered. So here for our parameters, we have a writer, we have a format string, and then we have values of any type, and so here I give it the writer, which is my response, and I give it a format string, right? And so here's the format string %v, and those format strings come from godoc.org/funct. Right, we have all these different format strings. So %v is the value in the default format. And default format values, the default format for %v is, if you use %v and it's a bool, it's really doing %t, which will show true or false. And if it's any of these, it's really doing %d for decimal. If it's any of these, it does %g, and %g is %G is large exponents. And then for a string, it does %S. For channel or pointer, it does %P. So control find %P. Base 16 notation, so hexadecimal with the leading OX.
So we're doing a string because we're doing the value of
Yeah,
a
so
field?
yeah, it's just a string, so we could do that. It would be the same thing. Let's run it, just check it. So that should have rebuilt. Image source. Break. So let's do %V, see if that changed it, if that was the change that killed it. So what happened there between those two, we have a anchor to the left and then just image source and a break. Does that one still work? I love it when things break. That one still works.
You need the anchor.
So maybe the anchor tag tells our browser that, just looking at image source, tells it the type, right? There you go. So what's that one I'm looking for is to fix that would be let me look here for a second and find it.
That is a funny error. Take out the A and all of a sudden don't really be code anymore. It's a funky font. Shouldn't funky font.
So I think this is what we need to add. Content type. I think we need to add that. Let's add that. See what happens. I don't know if we need content length. It would be length. And we could also just use this here. It's write string and format printf both. Except that one is wanting us to have a formatting verb, so let's do it like that. Length body. So instead here we're doing we're looping over stuff. So we just want this to print once. I'm going to move it up. And then I'm just going to take out content length and see if it still works. Let's try that. Rebuilt. Print it out as text plain. And so let's change it to what are content types? HTML content type. MIME type list. Text HTML. It's showing up as text HTML, HTTP1 200. Okay. But down here, it's saying text plain.
Because you're doing printf content. Do you have to do that, or does that just put that in the page? Change that.
Which one?
Like that printf, does that actually change the packet header, or does that just insert that text into the page? Like it says text HTML on the page, but the request header, packet header, doesn't.
Yeah, it says text plain.
So maybe there's some other function you have to use.
Yeah, I don't know. What happens if we do this? Do this one now.
Are you just trying to print the gifs without the link?
So now it's like totally not liking it. And if we get rid of that, I gotta get rid of IO. And if we look at get GIF, it's text HTML,
Oh, well.
right? So somehow just doing it with the anchor tag lets it know it's HTML. But image source doesn't recognize that.
Well, you got image source on the right side of the image.
Just put empty hrefs.
That's the same, right?
This one?
Yeah, right to the right.
But
got
not
image
here.
source.
But not here.
What if you just take out the %v's inside of the href? Put empty.
Yeah, maybe, right?
Further troubleshooting.
That's what you're saying. Likes that. Weird. Playing with an example live. All right. Make sure that works. There we go. Still working. All right, so that's doing a web API.